Hello, viewers. Welcome to my channel. Uh, and today with us is one of the finest mathematician and finest teacher of our country. And I am blessed enough to have him in my channel. And it's a great privilege for me that Professor Baba accepted my invitation and who really doesn't require any introduction as his service to mathematical society from past 2 decades is enough to say what kind of work he has done for our Society of Mathematics. And so, viewers, Professor Baba is teaching at IIT Guwahati from 1999, and along with his teaching process, he is also devoted to one of the most uh, successful training programs of our country, that is the Mtts program under uh, Professor S. Kumaresan. And I must say that he is one of the reason of the present growth of mathematics in the country, and also the those places which are less privileged in our country, that is like northeast region and most of the unprivileged regions which we have in our country. And this program has done a lot for those kind of students. So I came across Professor Baba in MTT's program, and I feel very blessed that I am under his guidance and continuing my learning process under him. And I also should not forget to share that he is one of the kind persons that I have ever met, and it's really honor for me and my channel, and my viewers will be blessed to listen to you, sir. And thank you for coming here. I welcome you from my bottom of my heart that uh, you are here with me. Thank you, Professor Baba.
Yeah, thank you, Gopal, for your very kind words about introduction. Just one disclaimer.
Yes.
See that when you say a mathematician, usually we assign the contribution in terms of research and all. So of course, I mean, I cannot be termed as one of the finest mathematicians, but of course, you can say that one of the, I mean, teachers who are striving to reach to a large audience, large number of students. Yes, rather than a, I mean, well-known researcher, I'm much more known as a teacher. Okay.
So
Yeah.
it's so kind that it's so kind of you that you're saying these words, but we all know what kind of potential you have and what you can do. But the thing is, you are serving the nation in the best thing what you can do for us. And with your service, a lot of students from India have benefited, and by Professor Kumaresan and all the team of MTTS that served a lot for this nation, and a lot of professors have been generated from this particular program. Now those who are in elite institutes working there, it's all because of you, means you people.
Yeah, I'm
So it's
one
really
of many.
appreciable.
Okay.
It's really
Yeah.
appreciable for
Yeah.
the team MTTS.
Yeah. That's
So
right.
thank you that
Mm.
you all have done so much for the country, and even you are
Yeah.
continuing this process from long time.
Yeah. Thank you. Mm.
So, Professor Baba, I have few questions that will be very helpful for the students if you like to answer those, and so
Sure.
they will be motivated enough by your words. I really feel like this because you are the those one of those best teachers that we have in our country. So, the first question that I would love to ask you is, what kept you motivated towards mathematics? How did you start this subject from your childhood days? What was the inspiration behind this?
Okay. I mean, probably I'm good at nothing else. Some bit in mathematics, that's why I pursued. But in fact, the interest it was generated in the very childhood. So my father, he was the first influencer. He is actually by profession, he was a pharmacist. But nevertheless, he engaged me in his day-to-day mathematical calculations. Of course, those are arithmetic. But I could see a purpose of doing what I did in my school. Okay. So that was the first thing. The second thing was, okay, I mean, I was pretty bad in arithmetic, by the way. Okay. I used to do a lot of silly mistakes. Okay. So then one of my teachers, so he found that I do, I mean, calculation mistakes, and he showed me how to check, okay, multiplication, correctness of multiplication. If which, I mean, you can, I mean, detect an error of 1 or 2 digits, okay, using that method. Probably you will also be knowing. So just think dividing by 9 and taking the residuals. Okay, so with this. So he taught me that. But I found that was almost, when he introduced me that one, it was almost like a magic. But because I mean that actually gives me that, good checking of my multiplications. Okay,
Okay.
I mean 2-digit numbers, 3-digit numbers, that kind of things. So, but that also made me to think how it works. Okay, how did it work? So that I tried to understand. I tried to know from my teacher. Of course, teacher didn't explain me. Of course, at that point, probably, I mean, this is not explainable also for a, I mean, primary student. But nevertheless, that kept me thinking. And of course, when I first came across geometry, that was very, very, I mean, motivating, right? And I think geometry was something which I enjoyed the most in my school. And then actually my teacher, one of my teachers, he found that somehow, I mean, that logical, okay, deduction and all, that I was sort of better than other things in the, I mean, mathematics curriculum. So I mean, he somehow he motivated me that yes, you have potential of doing mathematics later, because in school level mostly we do arithmetics, right? So, and that actually, that seeing or waiting to, I mean, waiting for something which will come, okay, which actually I'll be enjoying with my sort of, I mean, affinity towards logic. Okay. So, and that somehow that persuaded me to continue with this. And of course, as I said, probably, I mean, I could not have done much had there been no mathematics. Yeah.
Okay, sir. So it was a really motivating uh, story what you said. Like started from the school days, how your teacher motivated you, and you
Yeah.
kept your motivation alive, and now you are one of those best teachers that we have in our country. So, so Professor Baba, one more thing I would love to hear from you that uh, was you ever means thinking to come into this teaching journey, or you thought of something else uh, for
Okay.
your
I mean,
your
that is again, I
yourself?
mean, something which was put in my head
Okay,
by one of my teachers.
okay,
Okay. It was, he was a maths teacher,
yeah,
and he once actually it happened. It was in class 8 or 9, probably class 8 itself. So something of geometry was being discussed, and because I was murmuring something, so he called me. He called me that, do you have? Can you explain what's going on here? So it was essentially something, a small result of geometry and proof. So basically, he asked me to prove on the board. And I don't know. I mean, somehow I managed, but he noticed something. And when I passed my class 10, he said one thing that Baba, you see that, I mean, I will not tell you what profession, I mean, what kind of line, what stream you study in. Maybe you may go for engineering, you may go for medicine or anything else, but but I think you'll do the best if you be a teacher. Okay. So that also strike. I mean, somehow that was in me, and that's why I used to, I mean, enjoy explaining things to my friends whenever, I mean, whatever mathematics we discuss in. Yeah, yeah.
So it was again a great uh, story what you are saying, that these things kept you to keep your motivation continuing towards the teaching journey. So
Yeah.
one thing I would like to ask you again, that how should a student should do mathematics while he's in school level? Like should he do uh, means he should come up with new varieties of methods, or he should follow one particular methods and score good marks? Like that he can keep his motivation alive, or should he make some new methods so that he can be motivated in some other way, like some different uh, way of learning mathematics? So should he follow one this path, or should he follow the other one? Like,
Okay. Uh, Again, I say one thing about my experience. When I was in college, I stayed in a hostel, and my roommates, I mean, roommate as well as my other friends in the hostel, they were not from mathematics. Okay. And they used to see me lying down in my bed and reading a mathematics book. Okay. So, and they wondered whether I'm doing mathematics or history or reading some novel. Okay. So this is what, I mean, my experience is that, or my suggestion is that we have we have we have a saying that, I mean, see that we in our childhood also we do mathematics. Okay, we do mathematics. That means we do sums, right? So we read history, we read literature, okay, but we do mathematics, and that's wrong. And probably, most probably, that is where the problem lies. Okay, so one needs to read mathematics as well. I'll come to that in a minute. You see that our mathematics curriculum from the childhood, I mean from the primary level, when we studied mathematics, it was all algorithm. Okay, some rules, some procedures, and you follow these procedures correctly, right procedure correctly, you will get the answer. So that is what mathematics used to be in our time, our childhood, our days. Whether you talk about arithmetic, whether you talk about your algebra, okay, these are even up to your even class 12. You see that all are rules, the
yes,
differentiation, integration, okay, all these things. You take geometry, coordinate geometry, and various things. Almost all everything it comes like rule. I mean, or being taught. We're being taught like rules, procedures. You follow them and you find the answer. If you can do correctly, then you'll get the right answer. Otherwise, not. But the point is that is not mathematics. Okay, so that is that is something. It is okay. It is solving problem. So this characteristic of mathematics, okay, it actually drives away the students also, right? Now, even good students, they get demotivated when you put lot of rules and procedures, algorithms. Okay, even they get demotivated. This has been recognized even in India 30 years back. Okay, so in new education policy in 80s, then 90s, and especially in 2005, there is something called NCF, right? National Curriculum Framework.
same.
Okay, it was okay. I mean, it was led by, basically it was the exercise made by and CRT.
Hmm.
Okay, so that the entire attitude towards teaching and learning of mathematics, okay, that there is a need to change it, that was recognized. Okay, so in fact there has been a lot of efforts also to change this the algorithmic way of learning. New textbooks, okay, textbooks are written to a large extent up to at least class 7. They were successful in writing textbooks. Okay, these things, that efforts have been made, but the point is at the ground level that's not happening. You can write good books at the highest level, but it is the teachers who will implement it, right? So if you do not train your teachers, if teachers, they do not know that this is the new way of showing or teaching mathematics, then it is not successful. So my point is, you see that where I just give examples. I already said that, that question, how to check multiplication correct or not, that some algorithm was given. I was thinking for a long time. Why, how it works. Of course, when I was in class, 11 or 12, then I realized why it is so. Okay. Now, the as I have been saying, that the learning of mathematics is by the development of the thinking process. Okay. So, for example, maybe I mean, you may say that at say class 3 or 4, you cannot explain how you said 2 3-digit numbers you are multiplying. Okay, you're multiplying 2 3-digit numbers, the method. Okay, so this multiplying by first digit, okay, 10 digit, 100 digits, and then you do this takes sum. How it works, why you are doing it, how you are getting this product, probably you'll not be able to explain it to the student. But if it is not explainable to the student, why does he need to multiply 2 3-digit numbers? Are you getting my
Okay.
point?
Yes.
So that means, so uh, he doesn't know, why this multiplication of these numbers, what I'm going to do. And if he doesn't remember the procedure, he will not get marks, and he'll be
Demotivate.
scolded by the teacher, right?
And
So so that is important, that at some point of time, so at least suppose you introduce something to the students, some procedure, okay, if not at that point of time, at least within 2 years, that should be understood, the whole process, why it is so, why that method works, that should be understood by the student within 2 years. Okay, so this is what, for the teachers, or for us, the grown up. For the students, what I would like to say, that whatever, so doing mathematics and reading mathematics, okay, I say that you also need to read mathematics. Okay, it may be, your textbook may be very badly written. Okay, it depends on your board, it depends on various things, but there is a textbook. Okay, and in your textbook, your textbook of mathematics, okay, whatever book you have, that is not just a collection of problems. There are chapters. Okay, so every chapter will have something written. After that, there will be some examples, solve examples, then some exercises. So my appeal, my suggestion to the students, that, okay, you need to solve the problems. You need to you see the solve examples, but don't forget to read and understand the what is written in the chapter. I think that will solve a lot of problems. Yeah.
so for the viewers, I would say that please note these points. What Professor Baba is wanting to point out is what you are thinking of mathematics is completely different. What actually should be done with mathematics. You should not only do mathematics, but you should read mathematics. Professor Baba, one more question I would love to ask you, that as in these days, we see that students uh, feel very invaluable for those particular XY terms which we take during some problem solving. Like some abstractness comes when we are explaining some theory, so they feel it is not so much valuable at that time. So, what would you comment on this? And according to you, how these abstract thinking uh, are required for higher advanced mathematics learning?
Okay. See that when you use uh, actually
Sorry.
abstract thinking, it starts from the beginning itself. Numbers, they themselves are abstract. Okay? But somehow those are related to physical objects, like say 5 means 5 fingers. Okay.
Yes.
So this is I mean apprehendable. Now suppose, I mean, yeah, this is true that when we talk about variables, X, Y, Z, whatever it is, when you talk about variables, and then we have equations, and then suddenly a lot of new kind of mathematics is introduced to the students. But you see that it should not be, it should not go in one go. You talk about, so before that, before doing this, you have identities. Something like 5 plus 3 whole square, okay, a plus b whole square, that formula. Okay. A plus b equal to b plus a. This kind of thinking, no, those are also a. When you take about a and b, a plus b equal to b plus a, then a and b are generic numbers. Okay. So they are not, I mean, variables in, so I mean equations, but they are generic arbitrary element. So in some sense, they are variables. So I mean, before applying your, I mean, introducing your algebra. So these generalities. So first, so 5 plus 3 equal to 3 plus 5, 7 plus 6 equal to 6 plus 7, a plus b equal to b plus a. So see that, I mean, this is some way of generalizing, right? So this, the symbols, the application of symbols, it should come much before the variables done in algebra. Okay? So I think, I mean, that should help. And of course, uh, I mean, while using, because probably when a student come up to the level of algebra, till then he is trying to relate whatever he is studying, relating with practical applications and this and that. So maybe initially, I mean, when you say, when you even you bring an equation and say a linear equation and solve it, okay, solutions, or say quadratic equation and solve it, or say, I mean, using in algebraic identities. Before doing this, of course, those should be brought, those can be, those can be brought with the necessities. Okay. Suppose I tell you, I ask you, I mean, I ask the student, okay, I know that sum of two numbers is something and product is something. What are the two numbers? Okay.
Yes.
So then the necessity of this thing that can be brought, right? So, and that is probably, that is how, as you see in Mtts, we do
Yes.
not go for directly, I mean, just give a theorem and then prove and this. So it is developed. Okay. So idea also needs to be developed in a very, very, I mean, careful manner, because students at that level, they're very tender. Okay. So their minds, so that can be properly handled. That's what I think. Yeah.
So one more question I have, that is how a teacher should make strategies to make the students comfortable with this subject, as this subject has always been a fear to young students, those who are in school, who started mathematics in their
Okay.
early age.
Yeah.
even
See
even
that.
some even
mm,
some students, they are happy with learning of mathematics, but few are there in the corner of the classrooms. They are really afraid of the subject and they really want to quit at very early age. So how the teacher should come up with some strategies to support those students, like how we do in uh, do with good students. Like we always approach them to make them understand a good concept. But whereas when it comes to poor thinking of those backbenchers, or what we say, those students, how to make them feel comfortable with this subject? How would be the strategy for this?
Okay. See that there cannot be a, I mean, recipe which will work for all, right?
Okay.
I mean, we have, the country is so vast. Our, I mean, different regions. Okay, their experiences, teachers' experiences different. But more, I mean, say we have different kind of schools, right? Even as you know, and you pointed out in at some point that we have diversity of schools, right? So, and this diversity is it also comes from economic strata and various things. Okay, geographical, economical. So the teachers, the situation in which the teacher is working is diverse. Okay, so same recipe will not work for all. But one thing is for clear. One thing is clear that a teacher can teach. Okay, if, okay, this I'm saying, not saying only if, a teacher can teach well if he or she is loved. Okay, and that love comes from passion and, I mean, and compassion. Okay, you need to be compassionate to the teachers, I mean students, your students. If you are, then actually the need of the students, okay, they will guide you. Okay, it need not come from Bhaba Sarma. Okay, but again, whatever I said, that what we need to, it at whatever the level, students, good, bad, whatever it is. Okay, so mathematics should not be thrust upon. Okay, so if it is trusted upon, then what will happen? They will not accept that. So with compassion and with, okay, I mean, that why I'm thinking in this way, what makes me to think in this way. If I can take the student in that line, probably a lot of things, of course, I mean, it's easier said than not doing, right? It's very difficult and situations, and I mean, I cannot imagine is the condition a teacher is in a classroom. Okay, there are many different kind of situations, but probably this is what the guideline is. Okay, if you understand the subject, okay, how I introduce something, okay, first you need to make your mind very clearly. Okay, how they will accept, how they will think properly along with me. Okay, so and one I mean thing what we always say, that thinking along with the student in the classroom, that is the best way of teaching. I think, I mean, beyond that probably it's difficult to say a generic thing, right? Yeah.
You quoted it so well that thinking along with students is the best thing to make
Yes.
them understand what the problem is. So you have been handling these kind of students from remote areas from a very long time. So how the students from those area have been grown, and how they reached to good places after coming to this kind of training. So because I can see many students in my town that they have passion, but because of those amenities, they have been deprived from these kind of education of higher studies. So, what would you suggest for those particular people to stay motivated towards mathematics?
Okay, so I assume that you you have taken into consideration that the student has already passed out from his school,
Yes,
his
he
or
is
her
now in
school,
college.
right?
He wants to
Okay.
join college and pursue
Yeah, yeah,
mathematics.
mm, yeah. Okay. So for undergraduate education,
Yes,
the very first thing is that it is not the place or even the institution. Okay, I mean, just because someone has come out from, say, from rural area or, I mean, geographical geographically disadvantaged area and then come out to some cities or this, one will get a very good undergraduate education. No, it's not that. Okay. Even in cities, even in good, we have seen that even in good institutions in cities and okay urban areas, students are not better off. A student is in a very good position if he or she has a teacher who is a motivating teacher. Okay, that is what is rare. That is what is rare, irrespective of your geography, irrespective of your social strata or economic strata. Now, point is, for a student who is very motivated, who wants to pursue mathematics, yes, I mean there are good institutions. I mean also the good curriculum. Okay, curriculum, the assessment kind of things. Okay, somewhere assessments are more challenging, more okay, and some places maybe otherwise good, but same as all kind of assessments. So I mean, students will just mug up and okay, and then prepare from last says past say several years question papers, and then okay, so I mean, so somehow I mean, believe me that from our experience, what we can see that entire country, just because some institution is very renowned and okay, they have fame, the students there are better off. It's not the case. You must have seen also in the
Mhm.
MTTS programs, right?
Yes.
So it is actually the kind of training they get, maybe from a teacher, maybe from a good book. Okay, even good books are teachers, good teachers. Okay, maybe even some good resource material available online. Okay? Not everything. I mean, if they talk about say, I mean, group theory, you'll get hell lot of I mean material, but not everything. I mean, many of the thing are worse than your books. Rather than going through, you better read books. But there are, if one can choose, if one can choose well, then there are good resources even then, even therein, okay, free of cost. It's available there. So what I feel, and I tell you, right now in IIT Guwahati, okay, we have one student we have seen who has joined as a PhD student. Okay. He had some little bit of exposure to MTTS, that's fine. But it was the motivation from MTTS and also from the teachers from the college. Okay. And that the role that the teachers, I mean, they played is motivating him, encouraging him. And that's required. Okay. If the teacher can motivate the student, okay, so I mean, so you can do that. Confidence, giving that confidence is that itself is a big deal. Okay, so if that confidence can be given by the teacher, and teacher motivates him how to start, maybe the teacher is not teaching him
Mhm.
but showing him, okay, I mean, some good books. Okay, so there are like Ramanujan, I mean, he did not have any teacher, right? Okay, so he so for a good student, if he is motivated, if he is encouraged, then he can do it. She can do it. Okay. Only thing she should have is some good material in the form of books, or also now in the form of, I mean, this online materials. And I can cite one, right? You must be aware of Professor Kumarishan's channel.
Yes. YouTube channel. Yes.
Professor Kumarishan, he has last 3 years, just starting before pandemic,
Yes.
he has produced more than 370 okay good
Quality of.
good I mean, yeah, okay, video lectures, and those lectures, of course, those who are viewing those, they can they're saying themselves that these are much better than books and the other classrooms. Okay, so the resources are there. So not to lose heart, okay, and to get encouraged that yes, we can do, I can do. Okay, yeah,
Thank you, Professor Baba, that you have motivated my viewers through your kind words and suggestions. And one final question, final thing I would love to ask you that as this is National Mathematics Day month, and Srinivas Ramanujan, the greatest mathematician born on this means particular day, 22nd December, in December 1987. 1887. I'm sorry. So the one final thing I would love to hear that uh, how Ramanujan's effect has been there uh, in all those maths lovers, as you are one of those uh, people that have you ever felt any inspiration like reading to his story or reading to his articles, whatever identities he has discovered? So, what would you say about Ramanujan? This we would love to hear
yeah,
from you. The
okay,
final
okay,
thing for the students.
yeah,
So,
of course. Yeah,
yes, please.
yeah. Uh, See that Ramanujan is has made every Indian proud, right?
Exactly.
So he's, I mean, and see, he could see. So here is a person who could see almost infinity, whereas others are, just at the natural numbers. So he could see infinity, and and the kind of things he wrote, just wrote, right? He did not, okay,
True.
calculation and all those. He just wrote one after another, one after another, just, and which are yet to be proved.
Yes.
Of course, a few of them, some of them are
Yes.
also wrong. It's not necessary that everything, but he could he could see the depth. He could see in his, so that is marvelous. No, so it makes every Indian proud. If you say that, I mean, India, okay, it was India where the zero as the numeral, okay, it as well as a number, it was developed, okay, it was created by Indians. So similarly, I'm proud of Ramanujan, like, of course, at equal footing, okay. Of course, there was some teaching or some learning is there from Ramanujan's story. You see that Ramanujan, he, so first of all, it is the intuition. It is the intuition, okay, and creation, okay, creativity, which is the driving force for mathematics. Okay, it is not something like logical deduction that is driving force. Okay, so that is one. But nevertheless, the logical deductions and bookkeeping, like that means writing proofs,
Mm.
that is also equally important, because that will convince others and will allow others to think further. Okay, so farmer wrote, okay, farmer wrote a result, farmer's last year, and he said that in the margin he wrote that I have a nice proof. Okay, so that was not what it became theorem. It became a theorem only in 1994 or 1995,
Mm.
when Andrew Wills, okay, he proved
Proved
it.
it.
So, and that tradition, somewhere you see that in our Indian tradition, everything is fine, but there is a lacking, which also manifested in Ramanujan's things. That Indian mathematics or Indian, our, if you say the slokas and various things, okay, various things when we say, then we do not deduct things. We just pronounce, okay, this is true, that is true, like theorems. We state theorems. Okay. So we knew many Pythagorean triplets. Okay. But we did not prove Pythagoras theorem. That I mean,
Hmm.
Pythagoras theorem is because of his name. We did not prove that, I mean, square of, okay, two sides,
Hmm.
okay, of a right angle triangle, sum of two sides squares is equal to the square of the hypotenuse. So that result we never proved. We have many Pythagorean triplets.
Yes.
Okay, some people they say that, okay, I mean, we proved, I mean, we had Pythagorean that theorem. No, because we did not prove it. Okay, we knew it probably. Maybe, I mean, we knew for some certain Pythagorean triplets we knew. Okay, that doesn't mean that we had Pythagoras theorem and we proved it. That tradition was not there. Okay, that why if it is so, so that if that tradition, the bookkeeping had been there in Indian tradition, though I mean in philosophy there used to be a lot of logic. Okay, so I mean, deducting something and body, body, and that kind of various. Okay, so that logic, some kind of logic is there, but not in mathematics, mathematical results, right? Had there been, I mean, had we have that kind of deductive logic along with our mathematics, okay, would have been, definitely would have been better than the Greek mathematics. Okay, we had also similar genius who could think. So probably that tradition was not there in Ramanujan. That's why he suffered.
Hmm.
You see that he wrote results.
Yes.
Okay, but he never know why, how he thought about it, why it is this, something. He never thought of the requirement, need of that,
Proof.
because that tradition, we do not have that tradition.
Hmm.
And that's why when he went to Britain, okay, when he went to Britain, when he said that you need to prove it, and he was
Hmm.
surprised. Why should? Right?
Exactly.
So anyway, so I mean, so my point is, today again, I mean, if we think if we think that we need to do or we will be doing mathematics, our students, okay, inspired, they should, I mean, everyone is inspired and everyone should be, okay, shown that Ramanujan was there, okay, a humble person who did miracles, okay, is there. But also this, in this mathematics day, also it, the message should be there that if you want to, understand what the mathematics of Ramanujan, then you have to learn mathematics. You have to learn modern mathematics. Okay, just saying that, okay, mathematics, Ramanujan was genius, okay, and then we just celebrate this thing. No. Okay, so to the capability of understanding
Understand.
Ramanujan's mathematics, we need to learn modern mathematics.
So, very nicely explained about the life and work of Ramanujan, Professor Baba. Thank you so much that you have took some time for me and my viewers, and it was really amazing that the way you explained all the small points that need to be corrected in school mathematics and in college mathematics. The students, the teachers, all should learn what you said, and I would love to point one small thing that already Professor Baba said that for Ramanujan, there was one teacher who actually made him to understand what is the requirement of proof uh, is there. Means what is the requirement of that proof was. Otherwise, Ramanujan was writing the identities, so because of his professor G.H. Hardy, he forced him to give the proofs, and finally the name Ramanujan was came in front of all the means all everywhere means everywhere in the world. The name Ramanujan uh, was what you say the flourish name that came, and so everyone should get one such teacher in his life, and A student should be very loyal to his teacher and should learn and understand what his teacher wants to uh, suggest him. This will keep the students grow in their life and to make their names in this world. So thank you, Professor Baba. I have you as my teacher. I'm blessed to have you, and thank you for motivating me in these days since I met you. And thank you so much for coming to my channel.
Yeah,
I
yeah,
hope that this will help to a lot of students, lot of teachers. That all your suggestions. Thank you, Professor Baba.
yeah. Thank you, and wish you a very happy National Mathematics Day, and to all the viewers. Thank you.
Thank you, Professor Baba, and wish you the same. Happy Mathematics
Thank,
Day.
thank you.
So, see you someday again in the channel with some more informative suggestions for the students and teachers.
Sure,
It was
sure.
really loving to hear you. Thank you, Professor Baba. Thank you so
Thank
much.
you. Thank you. Mhm.